Hi, welcome to Provoke Your Physics channel. Today we are going to discuss about how to measure the magnetic induction due to a current carrying long solenoid. So first of all, we must know what is a solenoid. Actually, solenoid is nothing but a long insulated wire wound helically, okay, as a coil having certain length. For a solenoid, the radius of the coil will be considered very small when I compare to the length of the coil. So how the coil would be? So this would be in this way. So this will be a solenoid. Okay. For the solenoid, by using Ampere circuit law, we are going to measure the what is the magnetic induction, especially inside the solenoid. For that, I am going to use a solenoid having the length L. Okay, the length L means this will be its length, and so this will be the direction of the current is moving, and it is the current will be coming out in this way. Direction of the current will be considered inside the solenoid. This will be the direction of the current, and so of course by using right hand thumb rule, I can measure or I can find the direction of the magnetic induction over every closed area. If I do so, I could find, see, if I am using the right hand thumb rule in this case, the magnetic induction will be moving inwards here, and the right side it will be moving outwards. Even here, so here the magnetic induction is moving. This is the direction of the current, and here the magnetic induction is moving in. Here the direction of the magnetic induction is moving out. If do so, okay, we could find one thing: the magnetic induction will be acting inside more, okay, then outside I can see the magnetic induction will be in this way and having the direction of the clockwise. Having the direction of clockwise. Similarly, even here, okay, if I do so, okay, we can have the direction of the magnetic induction will be there, okay, moving inwards, and here it will be moving outwards. Okay, so when we do so, the total magnetic induction will be maximum at the center. Total magnetic induction will be maximum at the center. So in order to measure the magnetic induction inside a coil, we are taking an Amperian loop. That is, so let us consider these four. That is, so this will be A, and this will be B, and this will be C, and this will be D. 4 Amperian loop. I already told you this will be the direction of the current. This will be the direction of the current. By applying Ampere circuit law in this loop, I can just take, that is, closed integral of B dot dl is equal to, of course, according to the formula, mu naught I enclosed. Mu naught I enclosed. Okay, right. Now, so the left side of the equation, actually the total length will be from A to D. So total closed loop will be A to D. Okay, the left side of the equation can be written. Okay, that is closed integral of A to B, B dot dl is equal to, okay, so closed integral of A to B, B dot dl plus closed integral of B to C, B dot dl plus closed integral of C to D, B dot dl plus closed integral of D to A, B dot dl. So that seems we can divide this into 4 different parts. That is A to B one part, B to C, C to D, then D to A. Okay, so in which I could see the one thing, that is D to A and B to C. Okay, so we can see the direction of the current in this way. The direction of the current in this way, and especially the direction of the current will be perpendicular to the area. Perpendicular to the area. Okay, so the two integral, that is closed integral of B to C, B dot dl is equal to closed integral of d to a b dot dl is equal to 0. Why? There the angle will be 90 degree. And so what happened to C2D? That is closed integral of C2D b dot dl is also equal to 0. Why? There is no flow of current. Because according to Ampere's circuit law, B dot dl must be equal to mu naught times I enclosed. There is no current is flowing there. So I can simply take. So these three terms D2A, so C2D, B2A will be 0. The only contribution will be A to B. That is closed integral of A to B, B dot dl will be equal to, of course, mu naught times I. Mu naught times I. Now, so this is a small length, but here we have the entire length. In order to measure the magnetic induction of the entire length, okay, so simply I can just take, that is the total length will be L. So B times of L is equal to mu naught times I. So B will be equal to, okay, mu naught times I divided by L. Okay. Okay. Suppose if the coil will be containing n number of turns, that is capital N number of turns, then magnetic induction B will be equal to, okay, mu naught times N into I divided by L. Now we are going to introduce the new term that is called number density. Number density is nothing but number of turns divided by length. Number of turns divided by length. Okay, simply it can be written N, that is equal to capital N divided by L. So simply instead of N divided by L, I can simply write B will be equal to, okay, mu naught N I. What is this? This is nothing but the magnetic induction due to a long solenoid. Remember, when I am considering the solenoid here, the radius of the coil can be considered very small compared to the length of the coil. Thank you. If you like this video, like, share and subscribe. Thank you.